So this is the code where we left off in video number 14. In video number 15 I was talking about the OBJ file format, and in video 16 I just coded the OBJ loader file or class. So in the 17 I'm going to load the OBJ file into our OpenGL application. So I'm going to delete all these indices and vertices here. We don't need it anymore. And I'm going to import my OBJ loader. So from OBJ loader import all. From OBJ loader import all. So here I'm going to create an OBJ object, OBJ loader, and call the load model method and give it the cube.obj file. So res, it is under the res folder, and cube.obj. So res and cube.obj. So I'm going to generate a VBO, but I'm gonna change this to, instead of cube.item size, obj.model.item size with the length of obj.model, and obj.model is the actual data. Okay, I'm don't gonna use element buffers. So I'm gonna delete these lines. And the position is obj.model.item size times 3. Yes, times 3, because we have 3 float values. We don't need the color either, so I'm gonna delete this. And the texture, I'm gonna change the attribute pointer to 1. It has 2 float values, and it will be the obj.model.item size times 2. And yes, enable vertex attribute array 1. So for now I'm not gonna use the normal information. I'm gonna use it later when I'm going to do lighting tutorials. So I'm gonna just comment these two lines out. So now the model is extended only by the vertex coordinates and the texture coordinates. So back to the main app, and I need to calculate the stride, which is when I open the cube. So the stride will be, we have for the vertex texture coordinates, we have 2, 4 and 6 in a triangle, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 triangles, which is times 6, which is 72. 72. Yes, we have 72 texture coordinates, and each coordinate has 4 bytes, so 72 times 4 is 288. So let's double check. 72 times 4, yes, 288. So that's it. I'm gonna load the cube underscore texture.jpg. And we are going to replace this with GeoDraw arrays. GeoDraw arrays and GeoTriangles. Oops. 0 and the length of obj dot the vertex index. So I need to double check. So the next thing is just change. I created a new vertex and a new fragment shader, just copied from video 14. So I'm gonna delete this vector free color, and the location layout I'm gonna give it 1. So vector 2 texture codes. This is okay. Out vector new texture is okay. I don't need this. And position is okay. New color, I don't need either this. So new texture, which is here, is set to texture codes, which comes from here. And in the fragment shader, I don't need this new color. I need the input vector to new texture, as it is this, out vector to new texture with the same name. Out vector, out color is okay, and out color text of sample 10, I'm gonna get rid of this. So I'm gonna try it out, how it looks now. Okay, we have a cube loaded from the OpenGL file, but not the textures. First of all, I'm going to make the field of view, let's say 65 degrees. Okay, and textures, cube texture. So first of all, I just forgot to change this to video 17 vert and video 17 frag, and my offset is wrong. So how to calculate the offset? So let's say it has, every triangle has 3 vertices, every 3 vertices have 3 values, so 3, 6 and 9 times the number of triangles, which is 12, so 9 times 12 is 108, and times the 4 bytes, which is 432. So change this to 432. Yes, now the textures are loaded, although some sides are just black, and that's because we need to flip the image data. So I'm gonna create a flipped image variable, and it will be equal to the image image.transpose image.transpose and image.flip top bottom. So now it should work as expected, or not? Yeah. I'm just forgot to copy the flipped image and change this image.getData to flipped image.getData. Okay, so now it reads the cube OBJ file with the texture coordinates. So inside Blender, I just textured one of the Blender's model, which called Susan, a monkey head, and I just UV unwrapped it and just quickly textured it, so it looks like this. Not the most beautiest texturing, but for demonstration purposes it's okay. So don't forget, when you export out your model, to include UVs. Don't need materials, but triangulate the faces. I already exported it, so I am gonna load into my application. So it is in the res folder and monkey. So monkey and monkey.obj, and the texture is in the monkey, and the texture name is monkey. But we need to recalculate the texture offset, but as this object file is large, so as you see, these are just the vertex coordinates, the vertex textures, the vertex normals, and these are all the faces, so I don't want to calculate this using a calculator. So we can calculate the vertex or the texture offset by, let's say, how many vertices we have in the monkey head. So we have, let's say, length of obj.vertex index, and it gives us 2904 vertices we have in this model. So each vertice have 3 float values, so times 3, and each float value is 4 bytes long, so times 4. So our texture offset is 34,848. So let's say 34,848. And yes. Now our textures are properly applied to our model. I'm gonna just rotate it on the Y. So there is our beautifully textured Susan model. And just going to create a variable called texture underscore offset and give it this value. I'm gonna delete this print statement. So times 3 times 4, we can simplify it to times 12, because 3 times 4. And the texture offset, Ctrl C, and replace this static value with the texture offset. It works like a charm, and I'm gonna try it out with a different model. I'm going to download something from the internet. So I find this beautiful monster model on the blend swap by D. Gordillo or Gordillo. Thank you, Mr. Gordillo, for your model. So downloaded it and of course opened it in Blender and exported it as OBJ file with triangulated faces and only with the diffuse texture. So now it is here under the monster folder. So I'm gonna change this to monster and this to monster, the texture to monster folder, and monster the JPEG, and I'm gonna slightly move it on the negative y, 3 units on the negative y, and let's say -2 in the z, and change the field of view to 85 degrees. So I think that's all I wanted to do. So let's see how it looks. Yeah. It's a beautiful monster. So see you in the next video.